let's take a look at this. So yesterday we were focused on how we could represent qualitative data. Today we're looking at quantitative. So again, I'll do some things by hand and then we'll kind of show you some other tricks that you have to kind of speed things up if you want to use your technology. So the first thing, this data represents the number of available cars in a household based on a random sample of 50 households. All right, remind me, how do we make a frequency and relative frequency distribution? We did those yesterday. What do we have to do? So we make that table. So we could call it the number of cars, frequency, and then you could do it in a separate table, or we could just do the relative frequency here. So it looks like my options are 0 through 5. Alright, how many times do we have 0? 4. And 1. So you guys all remember how to do those? So frequency distribution is still helpful even if we don't have qualitative data. How did we do the relative frequencies? Right. The frequency divided by the total. What is my total here? 50, because we have 50 cars, or 50 families. So we should have each of those frequencies divided by 50. Any questions on those? Now the reason this worked is because our data was discrete. When you don't have discrete data, then we have to look at some different options. One thing that we could do, whether our data is discrete or continuous, is a histogram. So a histogram is really just like a bar graph, but all the rectangles touch. And typically it's, if we have like discrete data like this, then it would be centered around your x value. So for instance, if I wanted to make a frequency distribution for this, or a frequency histogram, excuse me, which I think was example 2, but I'm going to do it on this slide so I can look at my data. We have my x-axis. I would actually go ahead and mark 0 as its own spot. And then let's see, my y-axis. And so then you draw your bars around this value. So my first one, 0, so I would draw a rectangle surrounding that 0. And then 1 had a frequency of 13, so all these are touching. What was that? 22. Do you guys understand how I did that? Unfortunately, Google Sheets will not make a true histogram. All it does is the bar graph, so it would separate those rectangles and draw the bars. Really, there's not much difference. Just this is what a true histogram is. We can do histograms on our graphing calculator, so I will kind of show you that today. The histogram is more beneficial, or can be more beneficial if we have continuous data. We might want to that instead of just the regular bar graph, but really there's not much difference. So if we have true continuous data, that means we have decimals, we have an infinite number of responses. We kind of have to break them into groups, so we call those classes. So just like our grading scale, it's kind of like classes. You know, if you have a percent within this window, you have an A. If you're in this window, you have a B. This window, you have a C. So those classes would be how we group our data. We need to, when we do those, we do intervals of data. I think, did I give you guys this definition, or do you have to write it down? I can't remember. So the classes are just the categories into which we group our data. Like this. So this is giving us the length of time in seconds for 45 eruptions at Old Faithful. I want frequency and relative frequency distribution. What would be the only difference between frequency and relative frequency if we put them on a graph? Yeah, the numbers on the y-axis, otherwise it looks the same. Okay, so here, this isn't continuous because it's all rounded to the nearest whole second, but we have a lot of different points. There's 45 different points. Do we have a lot of repeat values? No. So if we just have 45 points with a height of 1, that really doesn't show us much. So this might be a case where we want classes to kind of group some of our data together. So let's look, what is our lowest value? Okay. What's our highest value? 738, is that the highest? So sometimes I might tell you what to use for the classes. Here I really don't. So we have to come up with that on our own. So our time will be a range of values. And then we need to do the frequency and relative frequency. So let's say I want to go, I'm going to go ahead and just start at 670, and I want to start my next one at 680. This is what's considered a class width of 10. It's how far from one to the starting of the next. So I can't say this first one goes from 670 to 680, because then if I had a 680, I wouldn't know which one to put it in. So where should this one end? Okay, so the next one would be 680 to 689, 690 to 699. So then we have to count how many points go in each of those classes. Let's just kind of divvy it up so that we're not all counting. So, Ryan, why don't you do how many are between 670 and 680? 79, you girls 680 to 89, 690 to 99, 7 to 709, 710 to 719, 720, and then I'll do the last one. Quick check to make sure you didn't miss any. What should those add up to? 45, because I told you we had 45 points. And it does. So then to get our relative frequency, we do each of those divided by 45. We can keep a few decimal places. And what should all the relative frequencies add up to? 1. Potential that they couldn't due to rounding error, but it would be very, very close. All right. So if I wanted to make a frequency histogram, we could do this by hand, just like we did the last one, but I was going to show you how to do one on your calculator. I also wanted to tell you where, in case you forget it, if you guys have a textbook, even one per table is fine. If you look at page 86, it does have, like at the end of each section, it'll always have a blue box and it says technology step by step, and it tells you how to do things using different kinds of technology. So we have the calculator, we're doing the first one. First, 86. So that's just kind of as a reference if you are trying to do one later on. Okay, so the first thing I want you to do is go to Stat on your calculator, and we want number 1 to edit. Okay, there may or may not be data in here. So here is my first warning to you. We're going to use these lists a lot. Do not use the delete button to take the data out. When you use the delete, it wipes out that entire list, and then none of our calculations come out right. So if you want to clear it, all you have to do is highlight the title and hit clear, enter, and it'll wipe out everything from that list, but keep it there, keep the title there. So I have data in 3 of mine I have to clear out. All right, and then we're going to type all of our points in this L1. So you just type your number in, hit enter. So go ahead and do that for all 45 of our points. Can you guys read them on your paper, or do you need the bigger? I don't know if they're bigger up here or not. If you hit second and the y equals, this takes us into our stat plot menu. All right, let's go into plot number 1. Let's hit enter. Okay, first I want to turn this on. Our type. Go over, you want the third one, it looks like a histogram there. You can hit enter. The X list should say L1, that's saying where's our data. Frequency is 1, color, you don't have that because you don't have color options. All right, so is everybody there? Now, if I just graph this right now, I'm probably not going to see anything. We need to adjust our window. So let's go into the window. All right, so X-Min, think about our classes. What was the smallest class we did? Where did it begin? 670. So my X-Min, I'm going to do 670. My max, we ended at 739, right? So let's just go to the beginning of the next class, so that would have started at 740. The scale, that's like how wide your classes are. Have I lost you?
Oh, ours is. Yeah, that's what mine's doing. Yeah. It's just like.
Into stat plot. Oh, when you go, don't hit second window, just hit window. Anyone else having calculator problems? Okay. So the scale, that's our class width. That's how far it is from the beginning of one to the beginning of the next. So how wide were our classes? 10. So I'm going to count my trains here. All right, my y's, we might need to adjust. So what was our highest frequency that we had? So let's just go 0 to 50. We can let those count by 1. So now let's look at our graph. And so then it gives us a beautiful histogram. Right. So most of the time, I'm rarely going to have you draw a histogram by hand. If we're going to do one, I'll probably have you do it on a calculator. One request.
I wrote notes on some of them and I
Okay.
will double check them.
This one's in start with this. If you leave the stat plot turned on, then the graphing calculators don't work for anything else. So if you ever had a time when you came in and tried to graph something and your calculator wasn't working, that's why. So I would ask if you're using mine, if you can turn that stat plot off at the end, that would help tremendously with me not having to help people with their calculators the rest of the day. So to do that, you just go back into that stat plot, and we just want to turn that plot off, and then it'll graph our regular equations again. All right, any questions about that? Okay. The last, well, got a couple more pieces to look at. One more type of graph, stem and leaf plots. I've always kind of assumed that you've done stem and leaf plots before, but I found out last semester that they never had. Have you guys done stem and leaf ever? That used to be like a middle school thing, but maybe not anymore. Okay, so let's talk about stem and leaf. I think I'm going to nix this example. I'm going to add in one with less data. So if we're looking at a stem and leaf, it uses the digits to the left of the rightmost digit to form the stem. Each rightmost digit forms a leaf. Okay, that sounds really confusing. But if I took some data, let's say I had points 5, okay. If I were going to turn that into a stem and leaf, the stem is like my 10s digit, okay? The leaf is only 1 digit, so if my number was like 105, the stem would be 10. If it were like 2,225, my stem would have to be all this. So the stem is everything except the last digit. So 5, if that doesn't have a tens spot, what would my stem be? 0. And so we put these in order. We have 0, 1, 2, and 3. And then the leaf is our 1 spot. So the only one that had a stem of 0, the leaf was 5. Okay, then everything that had a stem of 1, we had a 3, 7, 7, 9. You do want to put these in order, so I gave them to you in order, but you would go small to large. If you have repeated values, you list them repeatedly. So everything with a stem of 2, that's a 1 and a 4. Stem of 3. Okay, the nice thing about this over a histogram, the histogram, you have like your range of values, but when you look back at that bar, you can tell me how many were between 670 and 679, but do you know what the original numbers were? No, we kind of lose that. Here, we can clearly tell, oh, I had 13, 17, 17, 19. You keep your original data that way. Do you guys understand how we set that up? So the leaf is only one digit. Make sure they're in numerical order as you go through that. If you have something with decimals, that's okay as well. So if my decimal was like 5.1, your stem is the 5, your leaf is the 1. So decimals work as well. So what I had for example 5 was a really large set of data. We may not make the whole stem and leaf for it. I have one that I want to kind of show you. Do you need another example of me creating one of these? Okay. So sometimes you might have like a ton of data. This was unemployment rates. And you could do, you notice my stems, I have like 4, 6, 5. You know, there's not very many stems, but we have a ton of points. So sometimes you might see one where they kind of split the data. So they might have 2 stems of 3, and you'll notice the first ones went up 0 through 4, and the second one's 5 through 9. So you might see one like that if there's a lot of data, just so you kind of know. Any questions about those? All right. Do you want me to keep going, or do you want me to stop for the day? Are you getting tired of listening to me talk yet? Probably wouldn't tell me if you were. It's one of those questions. There's some response bias. All right, a dot plot. We did one of those that very first day. Remember when I had you roll the dice and measure how many you got at a certain value, and you came up and you just put a dot there, so that was a dot plot. So they're kind of annoying because if you want to figure out how many responses, you have to sit and count all the dots. So they're not very helpful for that. But if you're just looking at like how spread out the data is, or a scenario where we had a lot of people and we wanted to kind of gather everyone's points at once, that works out well. So not one I'll use a lot because they're annoying to read, but we could certainly do it. So let's practice making one real quick. This is the data we have from our household cars. If I ask for a dot plot, you can look back. We even had the frequency distribution here, so you wouldn't have to recount everything. So my options, my y-axis is the number of cars. Oops, no, it's not. My x is the number of cars. The y is the number of households that had that. So my options for the number of cars, I could have had 0 cars, 1, 2, 3, 4, or 5. Okay, how many had 0 cars? Looking back where we counted them. 3. So you would just have 3 dots. You would want to ideally try to space those equally. The number that had 1 car, 13. Two cars, 22. So you can already probably see that this is kind of annoying. 3 cars,
7.
4 cars, and 5 cars. Alright, so we don't really want to count all those points, but this does give us a pretty good idea of what we call the shape of our data. We are going to talk a lot throughout the year of if things are skewed, if they're symmetric, uniform, those kinds of things. So I think I'm going to go ahead and stop, and I'm going to talk about the shape tomorrow, if that's okay. So right now I'm going to go ahead and give you the homework, but obviously I have just a small bit to finish tomorrow. So you will have some time to work on it tomorrow. I might also teach part of the next section tomorrow as well. So not necessarily a